All right, so this is a question of some algebra here. So for the first one, can everybody see my screen? Hello?
Yes, sir.
All right,
Yes, sir.
so first question, we are asked to solve for x. We are given, right, okay. We are given 5x minus 2 equals to 3. So this is an equation. We just want to remain with x on one side and everything else to the other side. So we have 5x is equals to 3 plus 2. 5x is equals to 5. We're trying to remove the 5. Since these two are multiplied together, to get rid of that 5, we have to divide by it, both sides. We end up with x being equals to 1 like that. So remember, I said on algebra, you should try to check if your answer is correct. So you plug in your x value or the answer you got back into your equation. So you have 5. Wherever I'm going to see x, I'm going to plug in 1 like that, minus 2. So I'm trying to check if my left-hand side will be the same as my right-hand side. So this will be 5 times 1, which will be 5, minus 2, and all of this will give me 3. So my left-hand side is the same as my right-hand side. So that means this answer of mine is correct. Right. So that was for 1 mark. That means there are a lot of steps that you can skip over. I just added those steps so that everyone can have a clear understanding what was happening. Any questions on this one?
No, sir.
All right. Next one, we have a fraction and another fraction. So let's see how we can tackle that one. So we're having 3x plus 1 over 3x squared, 3x minus 2. It's equals to x minus 2 over x plus 2 like that. Right. So for this one, what you can do, you can just take this denominator and multiply it this side. So you can multiply it over here. You can take this denominator, you can multiply it over here. Or the other approach you can try doing is to take everything to one side. So it's 3x plus 1 over 3x minus 2. And then this will be minus x minus 2 over x plus 2. It's equals to 0. These are fractions. We are trying to subtract these two fractions. We cannot do that if the denominators are not the same. So we need to find our LCD. I said the easiest method for you to work out your LCD is to take this denominator, write it as it is, take the other denominator, write it as it is, like that. And then from here, what you'll do, you'll say, okay, if I'm gonna cover up, do we have shapes here? Yeah, let's do this. I don't think we have shapes. Nope, we don't have shapes. Okay, we just use a color. So if I'm gonna cover up this denominator like that, what I'll remain with is that one, is that numerator, and this denominator. So that means what I'll write is whatever I had on the numerator plus 1 like that, and the denominator that remained, which is x plus 2 like that. Right. So we are done with everything to do with this fraction. Moving on to this side. So this side, if I'm going to close the x plus 2, I'm left with this guy, which is x minus 3x minus 2, and that guy. So whatever that was on the numerator, we'll write it as it is. So it will be this into x minus 2, and then that other denominator, which is 3x minus 2, like that. Right. So after this, we can now get rid of this denominator. Remember, we can only do this if we are equating this to 0. If we didn't have any equal to 0 over here, then we would have to keep this denominator throughout. I hope that one makes sense. Right. So to get rid of this denominator, we can multiply by it, both sides. So 3x minus 2, like that, x plus 2, and then this side also times 3x minus 2, and x plus 2. So that will cancel that. This times 0 just give you 0. So what you're left with over here is this. We have 3x plus 1. We have x plus 2. We have minus x minus 2, 3x minus 2, like that, equals to 0. So we have these brackets to take care of, so we can do that method, whether it's FOIL or whatever method you like using. So just make sure that this guy ends up multiplying this x and it ends up multiplying that. This one ends up multiplying that and it ends up multiplying that. For this one, you'll first deal with what's inside the brackets. So this will multiply that, that multiplies that, that multiplies that. After that, it suggests that you have another maybe bigger bracket over there. After that, whatever you will get after simplifying this whole multiplication here, or this whole product, you will then multiply that with this minus sign over here. Right. So let's get started. So here we'll have this times this, which is going to give us 3x squared. This times this, it's going to give us plus 6x. This times this is going to give us x. This times this is going to give us 2, like that. So all of this, it's just that guy, like that. Minus, so this times that gives us 3x squared. This times this gives us minus 2x. This times this gives us minus 6x. This and that gives us plus 4, like that. Right. Then from there, what we can do, can continue. We have 3x squared, like terms over here, plus 7x plus 2 minus here like terms, 3x squared minus 8x plus 4, like that, equals to 0. So we now need to multiply by this negative inside the bracket, like that. So this will still be 3x squared plus 7x plus 2 minus 3x squared plus 8x minus 4 equals to 0. And then still we look at like terms. Remember we said for like terms, you have to have the same variable or variables, and same exponents like that. So your x squared plus x cubed, even though they have the same variables, they don't have the same exponents, so those don't count as like terms. So also the order of things, so if you're having x squared y and then plus xy squared, same, the bases are okay, they are the same, but the exponents are not, because here you're having x having exponent 2, here you're having x having exponent 1, so these don't count as like terms as well. That's something to just remember, right? So this and that can count as like terms, that and that counts as like terms, this and that counts as like terms. So after identifying like terms, you take your coefficients of those like terms, and then you do some magic with them. So here it's just gonna be 3 minus 3. So that means this is 0. So we don't have anything that has x squared anymore. This one will be 7, which is plus 7, plus 8, and this will give us 15, I think. 15x. This is plus 2 minus 4. So you'll be having plus 2 minus 4, and that's supposed to give us minus 2 equals to 0, like that. Okay, let's see. Yeah, all right. So here, this would be 15 equals to 2. Divide by 15 both sides. You end up with your x being 2 over 15.
Oh.
Yeah?
-4. Okay.
All good. Hello? Everything good? Okay.
Yes, sir.
All right. So
Oh,
this
say
ends.
no, I was just yeah. I'm not sure it's negative multiplied by positive like 4. And then
Yeah.
you get a negative number.
Yeah.
And then the second bracket, shouldn't this 4 be negative?
Which bracket? Which second bracket?
I get the first bracket say.
Yeah.
No, no, la pants.
Okay. Here.
3x plus 6x plus x plus 2.
Okay. Here.
Ele.
Do we
Negative
have a minus?
multiplied by
Let me see. Do we have a minus? Okay. This is a plus 2. That's x plus 2 over down there. Where's the minus? This is 3x
so
plus 1, x plus 2 here. And then you come here, right? 3x squared plus 6x plus x plus 2.
minus ngifuna lo 4 se ulo 4.
Now 4, it's supposed to be here plus 4.
Se and then angisho positive multiplied by negative is negative, angithi?
Yes.
And then so here negative, okay, we negative 4 here. Se kulana angisho ngibona ngathi la lo 4 lona it needs to be negative 4 from ekuqaleni bafumfaka la kubo negative 4 and then negative multiplied by negative is positive 4.
Where did you start multiplying by negative now?
Say ngiqala ukumultiply ku-negative from the first step to the
All right.
second one.
Here. So it's minus negative times negative, or you're multiplying by this negative inside.
Say
This guy times this guy, right? It gives us plus 4.
Positive 4. And
This
then
is
this negative multiplied by positive 4 is going to be negative 4,
there you go.
right?
This is negative 4 over here, yeah?
Oh, so this step lapho bobonisa khona njengoba wenza i-fuel method asinaki.
Which one? Here? This step. This is me multiplying. Negative times this gives me that guy. This times that gives me that guy. This times that gives me that guy. It's this step.
Okay.
We only dealt with like terms over here. That's why we have the 8 here.
Okay.
All right. So we find out that's our final solution. So yeah, I think there's another way you could have done this. You could have just taken this guy, multiply this side, take this guy, multiply that side, and carry on. So yeah, that's that. Any questions on this one?
Ngicela lapho boso calculator khona ngobona.
Where?
Everywhere. Ama-step there.
Down here. All right, you good now? Kia, are you sorted now? Can I move on to the next question?
Oh, say.
Mm.
La angithi basifuna ukuchecka if i-right answer mele ukuthi sifake like open and close bracket of law 2/15.
Yeah.
And then mele ibe equals to 0 angithi.
If you are plugging it here, whatever number you will get this side has to be the same as the number you'll get on the other side. So let's check it.
Oh.
So it's gonna be 3 into 2/15, right? Plus 1
Plus
over.
1.
Let's hope it's correct. Like that. So you check what number do you get here, and then let's do this side as well. 2/15. 2/15. And then you'd have.
Hey.
Are we getting the values? 2/15 plus 2. So let's see if that is giving us something useful.
It's giving me -7/8.
This side.
Yes.
7/8. Did we all get this one? Are we getting the other side? 2/15 minus 2 all over 2/15 plus 2.
Right, sir. Negative
So
7/8.
Negative 7/8. So the left is equals to the right. So you're only gonna say it's supposed to be equal to 0 if you're gonna be using maybe this step over here, because this would give you equals to 0. But I suggest that you always go back to the start of the question, just in case here when you maybe transposed, you ended up having a plus instead. Can you see that? So you might have made a mistake here transposing. Maybe this is now a plus, maybe there you have a plus. So yeah, try going back to the actual question. Okay, moving on. We are having 1 not 1 point, but it's 3.1.3. So for that one, we are still solving for x. We are given x squared minus 4x equals to 21, like that. So this we can try and see if this qualifies to be a trinomial, because we cannot say we are looking for a common factor here and say x minus 4 equals to 21, and then we start now saying this, it's equals to 21, blah, blah, blah. So remember, I said you can only do this part like this if this is 0. So if it's not 0, you take this guy, transpose this side, and you try and factorize. So since this is not 0, we cannot do this. All right, let's do things right. So that means we take everything to one side, minus 4x, 21 equals to 0. Then we try and factorize
Sir,
this.
azaba khona nama-graph abo-hyperbola nabo-parabola laphaya.
Sorry?
Upaper one azaba khona ama-graph.
Functions, yeah. Yeah, I think it's part of paper one. Right. So this is a trinomial. It has 3 terms. So trinomial. So remember, we are trying to find the factors of 21 and the factors of 1 over here, such that when we add or subtract them, we end up with this middle term. So what are the factors of 21?
1
Factors?
times 21.
1 times 21. What's next?
So 3 times 7.
So you have 3 times 7. Is there anything else?
You think check.
I doubt.
All right. So,
Aphelele, sir.
I
all right. So we check if we're gonna add here, we'll get 22. If we subtract, we get 20. If we add here, we get 10. If we subtract, we get 4. So remember, we are trying to get this number over here, which is 4. So which of those are giving us a 4? 3 and 7, like that. So it means we can open 2 brackets equal to 0, x, x. I have one that has a 3, I have another one that has a 7. In terms of signs, this one, if it's a minus, it's telling me that I'm having different signs inside my brackets. This one is the sign of a bigger number. So sign of the bigger number. Bigger number. All right. So the bigger number between 3 and 7 is which one? I'm hoping it's 7. Like that. So since they're different, if I have a minus here, this will be a plus. So now I have factorized everything and I have equal to 0 over here. That means now I can say how?
Oh, okay. No, I just wanted to ask, ukuthi like, angisho uthi the bigger number gets the first sign le. So you don't have to put the negative sign ekuqala and then ufake bigger number switch ama number noma ungamultiplyanga kanjalo ukuze uthole ama factor. You can just take the number 2 ngale ndlela uwaplace ngakhona.
Yeah, for this one, since it doesn't make any difference if we start with a 7 or we started with a 3 for this one. But for those ones whereby you'll be having 2x squared, 2x here and whatnot, the arrangement of these numbers matter. Because if you're gonna multiply this like that, you'll get minus 14. If you'll be having 7 over here and 3 over here, you'll be getting something else, a 6. So that will become a factor. But in this case, since whether you'll be multiplying 1 times 3, you still get 3. 1 times 7, you still get 7. So it doesn't matter in this case. All right, so here we now have factorized. We don't have a 0 here. So we can say this bracket is able to give me 0. So I can say x plus 3 equals to 0. Or this bracket is able to give me 0. So all of this, what we are doing, we are saying, Guti, this could have been written like 0 times x minus 7, and then it was going to give me 0. That's what we are saying here. This bracket could be 0. If this whole bracket is 0, I multiply it by the other bracket, I can get 0. Or same thing, if the other bracket like this, I multiply it by 0, I can get 0. This is what the statement is saying. Right, from there you'll be having x, it's equals to minus 3, or x is equals to 7, like that. So we check if those values are solving our equation. So question was x squared minus 4x equals to 21. So wherever we're gonna see x, we're gonna plug in the values we got. So let's start with negative 3. Negative 3 all squared. Remember, negative 3 squared will not be the same as negative 3 all squared.
Hi, man. Ish.
What's wrong now? All right. So minus 4 into minus 3. Let's see. This gives us 9. This gives us plus 12. And then we get 21. So the left-hand side is the same as the right-hand side. Let's check the other one. If I'm having 7 squared, minus 4 into 7, this gives me 49. This gives me 28, and that should give me 21. So both answers are correct. Any questions on that one?
No, sir.
All right.
Then, khona lapho bowuthe if maybe awutholi ama-factors by the multiplication of these original numbers, you can multiply the numbers you used to multiply. Ukuthi uyithole.
If you can get,
Like, say, let's just say maybe low 1 times 27 or 3 times 7 couldn't give us 20. You say we can also use the method lena ye 1 times 3 and also 27 times 7 to check if we really can't have factors, I would say.
I'm trying to find a question that can solve that one. What we actually did on that question, let me see if I can find if I can think of something. So you'd be given something like this. So, let me see, I have a question like that close by. I think this is the one. 2x
So,
squared, yeah?
iphepha lamanje, is it provincial?
I think so, yeah, I think it's provincial. But I'm seeing different dates from what people are sending me. So, yeah. All right. So remember, we are looking for factors of this guy and factors of that guy, right? Factors of this guy, that's 2 and 1, right? Those are the factors of this guy. So let's say factors of 2 here. And then factors of this 2 is going to be 2 and 1 as well. So the reason why we didn't do this part on the previous question is because it was 1 times 1. So it doesn't matter. That's why we didn't do anything like this. So we are saying here, we're trying to get a way such that we end up having this 5 over here. So to do that, we can just take these 2, multiply them together. This will give me 4. This will give me 1. Another multiplication I could have done this one. So I could have, this is 2, this is 1. So I could have multiplied those 2, so it's going to give me 2. I could have multiplied those 2 like that, so it was going to give me 2. So this gives me 5, this gives me 4. So this was just to help us know which brackets, what to put inside the brackets. So the ones that we are looking for.
So sebayinje ufaka kanjani?
Brackets.
Okay. 4 no 1.
No. Let's try it out now. So I'm trying to end up with this scenario. I'm trying to end up with a scenario whereby 2 from this bracket multiplies the 2 from the other bracket. Because if I place them together, if I say 2x and 2 here, these 2 don't get multiplied together. But if I put this 2 over here, this will give me this 4. If I put this 1 over here and this 1 over there, this will give me that 1. Yes. This over here was going to give us, let's see. So that means I'm saying I'm supposed to multiply 2 and 1, so 2x times 1 over here. I'm supposed to multiply 2 and 1, so there'll be a 2 over here and the other one. So this will give me 2, this will give me 2. So adding or adding those two will give me 4, subtracting them will give me 0. Adding here will give me 5, subtracting will give me 3. So the one we are looking for is this one because it's giving us the 5 over there. There are different methods of doing this. This is the one I think it's a bit simpler. All right.
Okay.
Moving on. So 3.1.4. Wow, time is flying. So having 3x squared equals to x like that. Right. So here you don't just go about dividing like this and say like that. You don't go about doing that. So you take everything to one side first. So you have 3x squared minus x equals to 0. I have an equals to 0 here. This is not a trinomial. Let's see if common factor works. So common factor is x. I have, what's this? 3x minus 1 like that equals to 0. So since this is equals to 0, what I'm saying is that this x value could be 0, or this bracket over here could be 0. So I'll say x is equals to 0, or 3x minus 1 is equals to 0. This one is complete. Here, our x is equals to 1 over 3. So we can plug that in and see if it's giving us what we're looking for. So if we plug in x being 0, it's going to be 0 squared. And then we're supposed to get, this is going to be 0. We used 0, so we're supposed to get 0. And then the other one, it's going to be 3. 1 over 3 squared. So let's check here. Then this gives 3 into 1 over 9. This gives 1 over 3. And we were saying this is equals to, let me see, what's the original question? 3x squared equals to x. So whatever x value we used, it's supposed to be the actual answer. That's what we are saying. All right, moving on. If there are no questions on this one. Right, so 3.1.5. 3.1.5. We're still dealing with an equation. We're given x minus 3, x plus 4 equals to 0. So this is already equals to 0. There's no need for me to break the brackets here or to find the product of this. So if it was some other number or variable that was not 0, then I would have to use my FOIL method here, take whatever that's this side, bring it over, and then try to factorize again, and as long as I have 0 here. But since I have 0 over here, I can just say this bracket will give me 0, or that other bracket will give me 0. So it will be x minus 3 equals to 0, or x plus 4 equals to 0. I don't know why they gave that one 4 marks, but okay. So here it's just gonna be x, it's equals to 3, or x it's equals to -4. And those are your answers. Any questions on that one?
No, sir.
So we are saying if
Sir.
this is like this, yeah? If it was something like this. Yeah, if it was something like this. We cannot just say x minus 3 is equals to x. This is wrong. So what we have to do is use our FOIL method here, x squared plus 4x minus 3x minus 12 equals to x.
Sir.
X, yeah?
So like that's the legit answer.
This part,
No, the first one.
which one?
Yeah, that one that you just circled down.
Yeah, that's the actual answer. So here I'm just showing you that if there was something else here, then you'd have to take this to the other side first and make sure that you have an equal to 0. And now that you have
Oh,
equal to 0, you can now collect your like term. So this will be x squared. That's a like term, that's a like term, and that's a like term. So you'll end up with plus 4. Let me see. So it's going to be plus 4 minus 3 minus 1. So this is just 0. So I'll end up with something like this. And then I can carry on with life.
okay.
All right. Any questions on what we covered? Okay, I'll assume silence means no question. 3.1.6, it's an inequality. We have 2x minus 3 over 2, like that. 3x plus 1, like that. Right.
Oh,
So,
sir,
mhm. Sorry?
after this one.
Mhm.
After this one, I give you one ukuthi ngicela ungenzele yona.
Okay.
Yeah.
All right. So this is an inequality. We're trying to find the range of values. So this won't be just one value. It would be a range of values. Could be 5 values, could be 100 values that will satisfy this inequality, this statement over here. So what we are looking for, values of x such that when we plug those values on this side, whatever we will get will always be greater or equals to whatever will be on this side. Right. So in terms of people being confused, what is greater and what is less than, we are saying that this part is small. This point over here is small. So whatever this small point is pointing at, this is less. Whatever this part is big. So whatever this side will be greater. That's it. Like that. So if it was, even if it was gonna be this being this side and this being this side, we flip the side, it's still gonna tell us that this part is less than the other part, something like that. All right. So to do that, we treat this as if it's it's an equation. The rules that will apply here, the only thing that will change this sign to face the other direction is if we divide by a negative. Right, so let's see. So this will be right. So first thing I'd like to do is to get rid of this 2 over here. So I can multiply by 2 both sides. So I'll have 2x minus 3 is greater or equals to, this will be 6 into x plus 1, like that. Right. And then now this 6 part can multiply everything in the bracket. So it's 2x minus 3 is greater or equal to 6x plus 6, like that. Now I can try taking everything to one side, or I can collect all the variables one side. So I have 2x minus 6x, like this, 6 plus 3. So this ends up giving me minus 4x greater and equals to, this is a 9. I'm getting rid of this minus 4, so I divide by minus 4, I divide by minus 4. So division by negative will flip this sign around. So it will be x like that. Now it will face the other side. So this will be minus 9 over 4 instead, like that. So what we are saying here is that if I'll take a value that is less than negative 9 over 4. So If this is my number line, that's 0. Negative 9 over 4. What's negative 9 over 4? That's 2 comma something. That's 2 point something. So negative 9 over 4. Any value remember, the values going this side are greater than this number. The values going that side are less than this number. So the more negative a number is actually the smaller it becomes. So negative 100, it's actually way, way smaller than this number over here. The more you go to the left, is the smaller the number becomes, right? So what we are saying here is that if I'm going to take any number that's to the left of this negative 9 over 4, then I'm always going to get my right-hand side being greater than my left-hand side. So let's try it out. Negative 9 over 4. All right. So give me a number that's less than negative 9 over 4. A number that's less than negative 9 over 4. A number that's less than negative 9 over 4. What does negative 9 over 4 give you on your calculator?
Negative 2,25.
All right, give me a number that's less than that one. Negative 1 or negative 3, which one?
-1.
Negative 3,25.
Negative 3. Let's use negative 3.
Okay.
Negative 1 is greater than that number. All right, minus 3 over 2. So this will give me minus 6, minus 3 over 2. This will give me minus 9 over 2, like that. Fine. This is my left-hand side. So we're saying this part on the right, on the left, will always be greater than whatever that will be here. So on the right-hand side, it's gonna be this. We said we're using minus 3 and plus 1, like that. So we end up with 3 into minus 2. We end up with minus 6. So what does negative 9 over 2 give you?
Negative 4,5.
So is negative 4,5 greater or less than negative 6?
Greater.
It's greater. So negative 4.5 is greater or equals to negative 6. So that means the values that we chose are satisfying the equation or the inequality there. Yeah. Does that make sense?
Yes, yeah.
All right.
Yeah.
Okay.
You said that you had a question. Yeah, give me that question. What's the question?
Okay. So, I actually have two.
All right, let's start with the
Question
first one.
understanding.
What's the question? Hello? Hello? Now I can hear you. What's the question?
Hello.
Can you send that to me via WhatsApp?
Okay. 2 8 like 2 8.
Send take a picture of it and send it to me via WhatsApp.
Right now.
All right, as we wait for that picture, let's look at this
Okay, let me
question.
try.
We're having x cubed minus x squared minus 2x equals to 0. So still solving for x, I have an equals to 0 here. That means I don't have to have anything crossing over. So the first thing I can try doing, it's common factor.
Factor. Mm-hmm.
So it would be x squared minus x minus 2 equals to 0. I don't divide by x and say then continue from there. So what I'm saying is, what we are saying here is that this x variable is equals to 0, or this bracket is equals to 0. So x equals to 0, or this whole bracket it's equals to 0. So this one, there's nothing more I can do about it. This is a trinomial, I can carry on. So it's a trinomial. We're looking for factors of 2 such that when we add or subtract them, I'm still waiting for that question on WhatsApp. It's not here yet. Oh, okay, it's here. All right, so I think even if we can do 2, 1 here. This is signs saying they're different, sign of a bigger number. This is the bigger number, and like that. So this is what we have. So this will just be x equals to 2, or x is equals to minus 1. So that means for that one, I have 3 answers, not 2 answers. So if I'm going to plug in 0, I'll have 0 cubed, which is 0, minus 0 squared, which is 0, minus 2 times 0, which is 0. So that's 0 equals to 0. So that one is fine. And then you plug in this value, and then you plug in the other value just to test as well, like that. So I did receive Kia's questions here. All right. So the first one, any questions on this one?
No, sir.
Right. So the key point, don't divide by x over here. If it was a number, if it was 5 or something, then you can divide by it, it's fine. But if it's a variable, then don't. All right. So the question that Kia sent us is this one. So it's 2 exponent a plus 1 minus 2 exponent a minus 1 over 2 exponent a, like that. Right. So the first thing that we have to remember, it's the laws of exponents over here. This is telling me that I had 2 bases that were the same. I had a 2 with base, I had base 2 with exponent a, that was multiplied by base 2 with exponent 1. And what happened there? We added the exponents. There you go, we added the exponents. Same thing here. I have a 2 with exponent a multiplied by 2 with exponent negative, like that. That part makes sense.
Yes, sir.
So that means this is just 2a times 2 exponent 1 minus 2a. Are you saying something? All right, like that. Right. So since there's a minus sign that's floating around over here, or since we have 2 terms, we cannot just say this cancels out that. We can only start canceling things out if we only have 1 term. So to do that, we can check this and that to be common factors. So we can take out 2a, and back our red, 2a, what remains is 2 minus 2 exponent negative 1, like that, divided by 2 exponent a, like that. So now this is 1 term. That means I can cancel that guy and that guy out. What I'm left with is just 2 minus this guy over here, like that. And then to solve this.
Whoa, Sam. Whoa, Sam.
Okay.
So what did you do?
Where? Common factor?
I common factor say if we common factor bekungamela ukuthi maybe uthi 1 minus
1 minus what? Here, these two are multiplied together, right? So if 2 exponent a was x, right? If it was x, let's just say all of this was x, and then maybe this was y like that. And then this one, it's still x, and that one is p like that. Common factor is x. What remains? This guy, which is y, minus what remains? This guy, which is p, like that. Are we together?
Yes, sir.
All right.
In
So
this
we
case, the common factor
2 exponent a. 2 exponent a, yes. All right. From there, this is our common factor. We have it. We are left with 2 minus 2 exponent negative 1 over 2 exponent a. So we said this is now one term. We can cancel out that guy and that guy. After canceling out those two, we are left with this. Now, this, from the laws of exponents, we know that if I have something with a negative exponent, I can have this as a positive exponent like that. So that means this will end up being 2 minus 1 over 2 like that. And then you can just continue simplifying that. So I'm hoping you will get 3 over 2. 3 over 2 as your final answer. Right.
Yes.
All right, there is a way for you to check Lamar these questions. Let me show you. So the question we were given is this. Let's check if we do have the correct answer. 2a plus 1 minus 2a minus 1 over 2 exponent a. So what you will do in your calculator, you'll choose a number that you can place instead of having a. So you can have your a being equals to 1. Let's just say your a is equals to 1. That means in your calculator, you'll punch in 1 plus 1 over here, minus 2, 1 minus 1 over, and then this would be 2, 1 like that. So check if that is giving you 3 over 2.
So wait, uti 1 was 1, then minus 2.
There's 2.
1 minus 1.
Yeah, 2 exponent 1 plus 1. We are just repeating what we have here on our equations, just that instead of having a, I'm now plugging in 1. I could have plugged in 10, I could have plugged in 100. It's still going to give me the same answer. We get the 3 over 2.
Yes, sir.
3 over 2. Right. So even if you're going to make this to be 4, it's supposed to give you 3 over 2. So that's how you can check if your answer is correct. Even if you can make that a to be 4 and have this being 4, this being 4, and this being 4 like that, you'll still get 3 over 2.
Yes, sir, you still get 3 over 2.
Wonderful. All right. The next question that Gia sent us here. Let's move on. This is the next question. I'm seeing time. We're out of time. Minus 4, like that. It's minus 1 over. With minus 1 over 2m. And then like that. I hope. All right. So we are having an inequality here, but now we are dealing with 2 inequality signs. So remember, whatever you'll do on this side, you'll do it on this side as well. We are trying to only be left with m. So to get rid of this 1 over 2, you can just multiply it by 2 this side, multiplied by 2 here, you multiply by 2 here. So this ends up being minus 8. This 2 is gone. You're left with minus m. And then this is 10. We divide by -1, divide by -1, divide by -1. They said a division by negative will change the signs. So this will end up being positive 8 greater and equals to m. This sign will also change like that, negative 10. So this ends up being your final solution. There's nothing more I can do there. Any other questions?
Sir,
Mm.
I buza kuqala buza.
It's okay. You can go ahead.
Sir, mina i-classmate yami sir uthe lo okay sir excuse the language. Ma uthe lo 1/2m bayathandana. So kumele uthi over 1/2m uphinde uthi over 1/2m ngoba ngeke bahlukane ngoba bayathandana. Mara la uthi ayi serious utsho kanje. So
You cannot say 1/2m, 1 over, I'm lost, Busi. Interpret them. Interpret, please. What's happening? Okay, what are you saying?
mina ngithi labantu laba abangi-explainele bathemele ukuthi uthole i-LCD la ngoba bayathandana lo -1/2m. So mele uthi over -1/2m nangale uthi -1/2m.
These two things are multiplied. I get -1/2m. These two things are multiplied. So how do you get rid of something that's multiplied? You divide by that. But in this case, you'll end up forgetting that you had a negative. You'll end up forgetting that these signs have to flip around. Does that make sense?
Oh.
So you could have just said this divided by that. Here you could have said 4 divided by 1/2. The issue is I'm avoiding that method because you'll forget these signs. Secondly, you will forget how to write this in your calculator. You'll write it wrong maybe and end up getting something else.
Oh, so sir, basesikhuluma amaqiniso angibonanga ukuthi wenzeni la. Angibonanga ukuthi wenzeni.
You didn't see what?
Uthe no, it's fine.
All right, next question. We are out of time.
So he said, if you have factorized, if you have to factorize, and then you're given 3 minus 27 over x squared.
All
How
right,
can you solve that?
Let me write it down. You said it was
3 minus 27 over x squared.
27 over x squared.
Parallel.
Nothing more. No equals to nothing.
No.
We're supposed to factorize this.
Yes, sir.
Okay, let's see. That's a weird question. Because the only thing I can think of is taking out 3 as your common factor here. And that's it.
Okay, what happened to the x squared?
You said x squared?
Yes, sir.
Oh, okay. If it's x squared, then we can work something. X squared like that.
Yeah.
All right, so we can do our LCD thing, right? So if we do our LCD here, our LCD is just x squared. So I mean 3x squared minus 27 like that. All good.
Okay.
And then from there, I can do my common factor, which is 3. So I end up with x squared minus 9. All of this is over x squared. Still to get
Yes, sir.
difference of two squares. So this will be 3 into x minus 3, x plus 3, and then all of this is over x squared like that. And then that's it.
Okay. Okay. Thank you.
All right. All right, we'll have a session tomorrow and hopefully manage to do more and more questions. All right, bye-bye.
Bye. Thank you, sir.